All right. Let's give everyone a couple of minutes to tune on in, and then we shall start. Hope everyone's doing well. Hope you're all having a good day and, importantly, a good week. And a good day, too. A good day is also important. So, just give a couple minutes for everyone for people to sort of come on in, and then we shall start today's webinar. Hello, Zabrana. Welcome to the chat. Okay, I think hopefully looking better, just a small change. So I think we're probably good to go. So, that said, hello everyone. Welcome to today's webinar Wednesday. Today's topic, learning the basics of API testing as well as why it's important. I'll be your expert for the session. My name is Benjamin Taylor, but of course you can just call me Benjamin. So, what are we doing today? What's this webinar? Why is it important? Why are we having 30 minutes to discuss it? Because, well, I think it's really, really important, and it should be a part of every tester's toolkit. So, what is this webinar? Well, primarily, I want to look at why we need to care about API testing. I think API testing is a super crucial aspect of our testing toolkit as software testers. But first we need to understand why that is. Then I want to have a look at the basics of API testing, so sort of how we can generally accomplish API testing. I'll be going into a fair bit of detail, but as we'll discuss, API testing isn't a one-stop shop solution. It does differ depending on the implementation of it, so general details will have to be given. As well as I want to have a look at what tools are there to accomplish API testing. What tools are currently out there right now, what's popular, and how we can use it ourselves. But first, we need to talk about why we care. So why do we care? Well, when we traditionally think about software testing, we can think of it as split between testing local software that is on our machine, which is probably what we're most familiar with. We can also think about remote testing. When we look at local testing, then we think about testing software in primarily two main sort of ways. First, with graphical user interfaces or GUIs. This is how most applications on your computer would function and how we can test them, as well as just most projects in general. GUIs are, for the end user, pretty important. But there's also CLIs, or command line interfaces. If you're not more in the developing or testing space, you probably don't use a command line interface as often, but it is still something that you can use to test and interact with your computer, especially the software that is on your computer. But what about remote software? Remote software is a little bit different though. Remote software can of course still be interacted with GUIs or also web interfaces, of course, using your standard web browsers. This is the most common way of interacting with them. And you still technically can also use command line interfaces to send those outbound requests onto different connections. But we also have something called APIs, or Application Programming Interface. And that is a really strong way of how we connect to other remote software or machines. So why do we actually care? Is API actually that common? Yes, it is. Google Maps, PayPal, Slack, Salesforce, applications and services that you probably use quite frequently, or at least I know I do. And whilst a lot of these services, well, all these services do have front-facing web pages for how we can interact with them, there are also more. There's APIs behind the surface that provide a far more direct method of communication, and direct, and I'd say consistent too. So we should use these APIs, and importantly, we need to test these APIs to make sure that they function as expected and they work just how we want them to. APIs normally are tested in the system integration stage of testing and really should be a key component of late stage testing. However, we will discuss a little way we can start talking about testing APIs even earlier later in the webinar. And even if the software that we're testing right now doesn't have APIs, it may also communicate with other services that do use APIs. So it's still a really good testing target to make sure that these other services we're counting on work accordingly and respond with information in the format that we're expecting, even if the software that we're testing doesn't actually use APIs themselves. So good to keep in mind, good to know all the same. So APIs themselves give us and exist to give us a clear and consistent way of communicating with remote services. We'll talk about it more as well, but APIs are sort of the endpoints or the access points to these services themselves, and it's a clear, funneled way. Think of it like a street or a driveway. You know that all requests are going to come in the same sort of way. You don't know what's going to come in, but at least you have a funneled system of where traffic is going to come from. Developers with APIs can sort of focus on how the API call will be structured, meaning what's expected, what's allowed, what kind of information should be provided and is given back. Whilst in testing, we can focus more on ensuring that sort of functionality. We all know that software can be written by developers and it can work for the intended scenario. But what about the unintended scenarios, and what about those edge cases? So us as software testers can look at ensuring that functionality is consistent with what it should be. And APIs are the entrance points to our system. Without the APIs, we would have difficulty actually communicating. And without APIs, let's look at that further. If we didn't have APIs and ways of communicating between two remote systems in a fixed format, then really we'd need to think about each sender and receiver pair agreeing on communication methods. Or rather, probably each receiver or end server has to make their own communication methods that everyone else has to agree to. And if we didn't have APIs, then there'd be no really easy, intuitive way to communicate with these external services. We'd have to develop this sort of handshake and data transfer every single time between what we're doing and these external services that we need to use. And just imagine needing to test or develop this. Having these independent systems work in completely different ways. It'd be madness, it'd be terribly difficult too. So thank God we don't live in that world. Thank God we do live in a world with APIs that we can actually use. But before we get too into the roots and the details of APIs, I do want to make one thing very clear. And that is that every single API is different. No matter what service we're looking at, no matter what company is behind the endpoints that we're testing or examining, every API is different, at least in some aspects, because the underlying product is different too. Of course, the basic rules might hold up between several different services. So if we're looking at, say, for Google, for example, we have Google Maps, but we also have their Google search and a variety of other things. We can sort of expect the basic rules would apply for a lot of Google's API services. But the actual implementations, both in terms of what happens inside and what may be given back to us, will greatly differ. So let's look at two API styles that are quite common for how we can get an understanding of APIs ourselves. As I take a little drink. First up, though, for our first API, and what I sort of want to focus on in this webinar, is REST API. REST stands for Representational State Transfer, which looks at a couple different, let's say, methods or states of data that it can be in, and how it can represent this during an API request. REST uses a variety of formats for data, like JSON or XML, as we can see on the screen as well. And you probably can see here that the JSON, pretty easy to understand about how it all works. The XML, whilst it's not indented and could be, is a little trickier to understand and takes a lot more space too. And it's sort of for this reason that normally with REST APIs, you do see them using JSON, and REST API is more commonly used than the alternative of SOAP API. SOAP stands for Simple Object Access Protocol. Unlike REST API, SOAP only uses XML, which means a lot of requests from SOAP can be maybe bloated isn't the right word, but they can be quite large and difficult to write. SOAP does pride itself on being fairly language and platform independent, however, as well as being quite secure. I would say SOAP isn't used as much anymore. REST API is a little newer and I'd say more capable, as well as just more friendly to use. But both are important to sort of at least be familiar with and how they work. But since REST API is more commonly used, and I'd say it provides an easier understanding point, let's talk about REST API and go into some details about it. First in REST API though, the calls, these are the requests that we make to the server and that the server responds back to us. Calls are broken into three main components. First is the URL. Then we have our HTTP REST method, or the method that we use to communicate. And finally, we have a header and body content. Technically, I suppose you could say the header and body content are actually two separate components of REST API, but as we'll discuss, they are quite similar, so it makes sense to cover them at the same time. So when we talk about URLs, this is, of course, URL is the Universal Resource Locator. This is the access point for our requests. This is where we're connecting to. Apologies if you can hear that in the background. But URLs is where we connect to. It's where we target our requests. Normally, URLs are a web-facing access point that we can connect to so that anyone on the internet can connect to that URL with their API request. However, unlike sort of standard URLs that we use in everyday, URLs or APIs aren't always web browser readable. We can't always make a web browser request to go to that specific URL that we use for APIs. Why? because the API isn't expecting a web browser to suddenly come knocking and say, "Hi, I want to see your web page." Sometimes it does work, and discuss a little bit about this further. But just know you can't always open up these API endpoints on web browsers and expect them to work. Of course, depending on what service and product we're looking at, the implementation of how the API works and it's expected to work greatly differs. Some services may be responsive from one page for all types of queries. This means you can just send to one specific URL any kind of query, any kind of call you want, and you'll get something back, as long as the call itself is valid. However, other services will need different URLs depending on the kind of request that we're making. So do keep in mind what kind of request you're looking to make in your URL, or what kind of request you're looking to make, and read the documentation of that service so you can better understand. And if there is no documentation, or you're writing the documentation, probably best to ask a developer how it all works if you can't see the code yourself. URLs are also quite commonly used to provide controlled database access. Of course, this depends on the implementation of the backend of what happens, but a lot of the time you are getting some sort of database access here in a controlled manner. Don't want to give the API caller full control of your database. At least I hope not. So that covers the URLs, and now we can move on to the HTTP methods. There are a fair number of HTTP methods that we can use when making API requests, but I just want to cover the main 5 that are the most useful to us in testing and also development. First up is the GET method. This retrieves some kind of resource information from the server. Let's call our endpoint a server. Makes things simple. GET is exactly what it sounds like. We ask the server, "Hey, I want some information about your resources." Could be multiple URIs, or universal resource indicators, or it could just be a general summary on that server itself, as well as what URIs it holds. But following the GET, we also have the POST. If getting is receiving the information from a server, POST is instead sending it out. We're telling the server, "Hey, I have this information here that I've included in the body and header content. I want you to post it yourself, and here it is." Of course, not all servers will expect posts. Some servers probably won't allow posts in general, but primarily they do. And normally how this works is when a server receives a post, it will return to the sender a URI identification number that can be used to retrieve that resource information at a later date. And why do we care about the resource information at a later date? Well, probably because we want to look at putting something else there. The put method replaces whatever is located in that URI on the server with brand new information. Put's really useful when you need to perform a full-on update and when something's gone wrong during the transfer, or you're fixing some errors, or you just need to update it in some way. Put says, whatever was there previously, don't worry about it. Instead, let's update and have a brand new resource there, essentially. Well, what if you don't want a brand new resource? Well, then you can use patch method. Patch instead says, I have this resource that I want to update, but I only want to update these specific fields on our resource. So it's quite useful, much better than a put request if you're only updating certain fields, or if you don't know if something has changed in the backend about that resource itself. Patches are much safer. Only really put something back if you are sure that it won't interfere with anything else in the system. And then finally, there's the delete, which removes the resource information. This normally can mean deleting it straight away so no one else can access it, or maybe it can be a scheduled delete. Although with data retention laws, maybe it needs to be held on to for some time, but it shouldn't be publicly accessible. Overall, these are the 5 sort of main methods of HTTP and REST API. But do know that, of course, a fun caveat exists. It depends on these implementations, because these are only the general rules. I do know for some services that they only expect GET requests. However, depending on what URL you're going to or what your body and header content is, it could instead be actually a PUT request or a POST request. So these are the general rules and formats that should be used, but do note that this isn't always the case. So read the documentation. That's the key takeaway, I'd say. And lastly, the last part of using REST API would be the body and header content. And so if we consider the URL of sort of who we're talking to, and we consider the HTTP method to be how we're talking, then the body and header content is what we're talking about. And we can consider these to be sort of the provided arguments to any kind of API requests that we do make. Often, in header and body content, this will include some kind of authentication token. So that authorizes us to make changes to either get information or put information back out there. As often, you probably don't want someone who isn't authenticated to make changes to your database system, which is what REST API is primarily used for. So, as far as how we do authentication, that is a bit complicated and goes into more detail than we have time for in today's webinar, but know there are ways to authenticate, mostly using tokens, but anyway. And then we have the actual data for the request itself. So what we're actually talking about and what we want to know from the system, or what we want to give the system. And using REST API, this is normally done in the JSON format. We can use other provided formats, but JSON is probably the most popular that we're using. Overall, I'd say the header does primarily include authentication information, as well as what's expected in the response or what response type should be used, whilst the body includes the actual usable data. Once again, this does differ by implementation methods. As I have found in some services that I've tested, it does actually want the authentication data in the body itself, which is a little weird, if I do say, but you just have to know and understand how this works. Once again, read the documentation, try it out yourself. Especially if you're looking at automating these, it's really important that you have the initial automation scripts correct. So how do we actually accomplish API testing ourselves? Well, there's a couple different tools we can use, and probably the most well-known is Postman. Postman is the sort of main stop for API testing. It allows us to specify our HTTP method, our endpoint, and then it has query params as well as body, which is our header and body content, and we can specify these as we need to. With Postman, you can have a variety of testing suites for your different API tests that you do, as well as individual tests of each. And Postman makes it really easy to manage and keep control of your complete API testing. So definitely a tool that if you are interested in API testing, I recommend picking up. It's fairly easy to get started with. It has a great deal of depth on what you can actually do with it. Then there's also SOAP UI. SOAP UI, as the name implies, is primarily there for SOAP testing, but it does also include REST API as well. In fact, we can see in the screenshot I have here, it uses a post method, so that's using REST. SOAP UI itself primarily focuses on looking at functional testing of APIs, but it even stretches that further into looking at performance testing, security, as well as mocking up endpoints, and primarily also looks at data-driven testing and even looking at reporting metrics as well. So SOAP UI is sort of a one-stop shop. It is open source as well, so if you are more comfortable with that, then it's a pretty good tool to use, even if it does look quite old. But beyond those two, if you want a more sort of hands-on code solution, then a lot of programming languages will have some libraries for performing API requests. But if you want a testing language, then why not check in on our favorite robot framework. It has the requests library, which is tailor-made for RESTful or REST API requests. And it is fairly easy to get started writing your own API requests in Robot Framework. Can take a little bit to learn about how it all works and how it functions, but it has several automatic checks built in place during requests, and I'd say it's fairly quick to use once you get up to speed with it. And as the last tool I want to look at today, I want to have a look at what happens if we want to start testing our APIs, but we don't actually have our APIs to test with. What do we do then? Well, in that case, we can look at WireMock. WireMock is a way of mocking up our API endpoints that may not be developed yet. This is really great if we're shifting left and starting our testing of our APIs earlier than they're actually developed. Especially if we're not looking at just the API, but instead the API is part of a process that needs to be run for our tests to actually fully work. With WireMock, you can create your own endpoints and program a bit of basic logic on how they respond to requests to make sure that the testing data that we're sending is correct to some degree, but also getting some useful data out. Of course, it is no replacement for the actual implementation, but as the name implies, it's a way of mocking up what we actually need so that later we can replace and test properly. In summary, I would say that APIs, in terms of testing, APIs provide connection points to remote software. They are our main way of communicating with remote software that we need to talk to, that we need to test and make sure that they function as expected. APIs detail how the software may be used. There are limitations to the API. Of course, we don't want to give someone access, even if they have authorization, access to everything in the system. So APIs are ways to sort of limit how people can interact. APIs are, of course, GUI free, so they are, I'd say, a little bit faster to develop and mock up. For end users, you'll often find APIs exist long before web interfaces or GUI interfaces exist. So they are quick to put out there, and they're really good for providing some sort of templates on how requests in general can be made. And once you understand APIs and have tested a system pretty well, I'd say you probably understand APIs really well in general too. So that pretty much covers it for today's webinar, I'd say. Of course, happy to take any questions if there are any in the chat. Please do feel free to put them down. I'd love to see them, and I hope I'll do my absolute best I can to answer them too. So, in the meantime, whilst I wait for questions to come in, if you enjoyed today's webinar and you are not already following us on LinkedIn, then why not go ahead and check us out? Sign up, follow us on LinkedIn, and stay tuned to all of our future Wednesday webinars as well, including one that I'm doing next week. And if you want to know more about us at Go Bigger, then why not go ahead and check out our shop to stay up to date with our available courses. courses and offerings. Currently, we're looking at Robot Framework, and I have a hands-on workshop that also goes over API testing with some examples and assignments so you can get a better feeling of API testing yourself. And if you want to know even more about us, then why not stay up to date with our monthly newsletter of Grow Bigger. We promise it's only once a month, and we'll keep you up to date with all of our upcoming webinars, any happenings in Go Bigger, so new certifications, new courses, well as any deals or specials, and what's happening in the testing world in general. Highly recommend signing up and keeping up to date with that. And that brings us to the end of today's webinar, but I do see a question in the chat, so let's have a look at that. Have I used Bruno before? Postman's really slow in making the licensing. Okay, I have not used Bruno before, actually. I can't say I'm all too familiar with it. I have used Postman in the past, although this was a little bit ago, so I'm not too sure if I've been affected, or I've seen the updated licensing for it. Of course, these were just recommendations on various tools that you can use. So always do keep in mind, perform a bit of your own research, or see if you are testing what other people around you are already using in their testing endeavors. But Bruno does sound interesting. I'm not going to perform the research right now, of course, but I will look at that after the stream, so thank you for bringing that to my attention. If there are any other questions, please do feel free to ask. But it is already over 1 o'clock, so I understand if people have to get back to work. That looks good. Okay then. In that case, thank you everyone for tuning in. I hope you enjoyed today's webinar Wednesday, looking at the basics of API testing. Next week, I'm back again with a brand new topic, and I hope you'll find it quite interesting. Stay tuned to LinkedIn to see the event as it goes live. But in the meantime, have yourselves a wonderful rest of the day. Have a wonderful week, and hopefully I'll see you back here next Wednesday for the next Webinar Wednesday. Until then, see ya.